Hi everyone! Simulation nodes, they seem so scary and different, but luckily they're a bit easier to understand than you might think. Today we're gonna make this procedural worm animation. There's no keyframes here, everything is done with the simulation node, and it even leaves a lovely trail. Before we begin, if this tutorial is useful to you, please consider liking the video, it really helps me out, and you can subscribe to stay updated on future tutorials. To use these simulation nodes, you will need Blender 3.5 Alpha and specifically the version that has the simulation nodes. You can find it on the website or by clicking the link in the description. And the first thing we're going to do is delete our default cube and add a plane. This is going to be the ground that the worm is moving over. Let's subdivide this mesh by going into edit mode and clicking subdivide. Let's do 10 and then subdivide and do another 4. Let's start with that. And we're going to go ahead and create a simple terrain. It doesn't really matter, you can change this afterwards, but this is just to show how this add-on works. And then we want to go back into object mode and add a curve by pressing Shift A, going to curve and adding a Bezier curve. You can't see it, so let's bring it up a little bit. And actually we want to draw the curve across the surface. To do that, you go into edit mode by clicking tab. And we're going to delete all the vertices by pressing A and pressing delete. Next we want to go over to this menu here and click the draw option. So to draw on the surface of the mesh, we first click N and go over to our tool tab over here. And instead of cursor, we're going to choose surface. Now all we do is create a path like this. And we have a curve that's going over our geometry. We can try and make it a little more accurate by changing this value. We don't want to make it too detailed. I guess that's fine. And let's go back into object mode and open our geometry nodes editor, which is right here, and create a new group. Now before we do anything with these geometry nodes, we're going to go down to the curve menu over here, or the object data properties, and set the resolution to 1. This is because we're going to subdivide it in the geometry nodes, and I like to have one counter that subdivides it, so not a few subdivisions here and then a few subdivisions in the geometry nodes. It gets confusing. And let's also hide our surface geometry by selecting it and pressing H. Going back to our curve, the first thing we're going to add is a subdivide curve node, and let's set that to 100. This will make our curve nice and smooth, and that's right how we want it. Next we will add a curve to mesh node. The profile of our curve is going to be a circle, so let's select the curve circle, very important, select the curve circle, not the mesh circle. And let's set the radius to 64 and connect that as our profile curve. Now we will see that it gets way too big, it looks terrible, so let's just bring this down a little bit. I'm going to bring it down to 0.1. Another thing we want to do is click fill caps. This will fill up the end and starting point of the curve. And to actually make the worm shape, we're going to create another node called the curve radius node. Actually, it's the set curve radius node. And we're first going to give it a thickness based on the factor of the curve. The factor is 0 at the beginning and counts to 1 at the end of the curve. To do that, we will just add a spline parameter node. And we will also add a float curve. Connect the factor to the value. And the value to the radius. Now we can already see, because the factor is 0 to 1, it's actually very thin here and it has a thickness of 1 here. But we want to change that with the float curve. Another problem we have is that it's along the whole path of the worm. This is actually not the worm itself, but of course the path that the worm is traveling on. It's going to be very hard to actually make our worm when it's that long. So let's create a trim curve node so we can trim that curve a little bit. I'm going to set it to length and let's make it 2 meters. It's a pretty long worm, but you can also scale it. So let's make our shape by bringing the float curve out. And to actually make a tube-like shape is kind of a pain in the ass because we don't really have rounded edges in geometry nodes yet for curves. So let's just try and see what we can do by bringing this down, adding another point, bringing that up, Okay. It's now very thick, so let's place a math node in between here. And set that to multiply. Let's multiply it by, let's say, 0.4. Actually, I didn't do such a bad job with how the ends look. Maybe we can refine it a little more. Yeah, so it's very difficult to not get this pointed edge. One thing I did try was placing a point right here and then bringing this up a little bit. And then it actually gets a round tip. But as you can see, it's very, very hard to deal with. So you're gonna have to play around with that. Also know that the shading changes a lot of how it looks afterwards. You can see the imperfection now, but when the material is added, you might not even see it anymore. Now we also want to recreate this ribbed surface worms are known for. So how do we do that? We do that with the sign node. So that's actually in the math node. So let's duplicate this and set it to sign. What the sign operation does, of course, is it transforms a linear curve like this into an oscillating curve like this. And that's exactly the kind of shape that we want for our worm. So let's plug in our factor. And now the output will actually be between -1 and 1. So we don't want to give it a thickness of -1. So we're going to fix that by setting a map range node in between here. And it's going to go from -1 to 1 to a new minus a maximum. What we are essentially doing is the curve is now like this. So a part is below 0, which we don't want. And what we want to do is create basically this. So we have this ribbed surface, but there is a thickness here. So let's say we set the map range node from -1 to 1 to a new value of 0.85 to 1 and multiply that with our result. So it still kind of looks bad, right? We don't see any ripples. It's just gotten a bit thicker. So what's going on? Well, actually, we're seeing a sine wave, but it's very stretched out. It has a very low frequency. So to increase the frequency, we will just add another math node, set it to multiply, and let's multiply that by 200 so that the frequency becomes much, much higher. Set that to, and we have our shape essentially. To make things a little easier to see, I'm just gonna add a join geometry node so we can see our original curve here. So that's gonna be the path that it travels along. We can even maybe extend it out a little bit. Like that. If we go now to our trim curve node, we can start to play around with these values, and you will see that it actually stretches out and bunches up naturally, kind of like a real worm would do. We're only missing one thing though, and that's that a worm gets thicker when it bunches up. So we see it bunching up, but the thickness doesn't change. So we're going to quickly fix that. It's an easy fix. Let's pull this down a little bit, and let's get a curve length node. And we're going to plug our curve in after it's trimmed. So if we think about it, we want the worm to get thicker when it's more bunched up. So when the curve it's projected from is smaller. That means the thickness of the worm is inversely proportional to the length of the curve. So what does that look like in math? Well, I will show you. We're going to add another math node, and we're going to set it to divide. And we're going to divide 1 by our length. And let's also get another multiply node and put it in between here. And let's connect our value to it. Okay, we have a result. Let's see what happens when we actually bunch it up. And we can see that the worm gets a lot thicker when it's bunched up like that, which is exactly what we want. We can now still change the thickness of the worm by just plugging another multiply node in between here and just setting this to a value we like. I actually kind of like how it is right now, so I'm just going to keep this at 1, but I'm going to keep the node around so I can change it later. Okay, so now it's time to use the simulation nodes. We're going to go back all the way to the beginning, pull this out a little bit, and by shift right clicking I can make this into 1 point, so it's a bit easier to work with. And we are going to go to shift A and create the new simulation node. Create an input, and we're going to create an output. And how the simulation node works is whatever action is in between here, it's going to repeat that action every frame. So for instance, we can put a transform node into here and press play. Nothing happens, of course. But if we set the transform node to, let's say, 0.1 on the x-axis and let it play, we can see that our worm is flying off. Notice how nothing is actually connected to this translation. So it's just adding 0.1 every frame, and that makes it move. And now the really cool thing you can do is you can put an attribute here and add 1 to the attribute. And then next frame, it's going to use that attribute, but it's got 1 added to it. And so you can create these loops where values are rising, falling, they can do whatever. And there are some really powerful effects you can make with that. So let's just get rid of our transform node here. First thing we're going to add is a store named attribute node. And we're going to put that before our simulation node. The reason we put it before the simulation input is because it needs an initial condition. And this is setting the initial condition. We're going to give it a name. Let's give it the name start, because it's going to be representing the start of our curve, which is going to be trimmed up. And let's duplicate this node and put it after the input right here. Now, if we get the named attribute node and fill in our start attribute right here. And we also get a math node and set it to add. And let's say we add 0.01. And we do that every frame. So every frame we're going to add 1 to the attribute. Connect that to our value. And then we're also going to connect this attribute to our start input here. It's gone back to the beginning. So let's just quickly pull up a timeline here. So we... And let's press play, see what happens. Okay, so we see that our starting point is slithering along the curve. It's gonna bunch up and create something very weird in a second. Look at that. Okay, pretty interesting, but not how a worm works, of course. If you've seen a worm in real life, you will know exactly how they move. They will move their front part first, and then their back part, and then they'll move like this, and then move like that across the surface, and that is exactly what we're going to make. We're going to create a new attribute, which is going to be our sine attribute, because we're going to do this with sine waves. Let's call it sine, and put the same attribute in our simulation as well. Get this over here for a sec. We're going to duplicate this named attribute and this math node, and set the math node to sine, and set the named attribute also to sine. We're going to connect our attribute. And of course, the sine wave goes from -1 to 1. We don't want to deal with the minus numbers, so let's get a map range node. And set the range from -1 to 1 to 0 to 1. Let's connect that. Move it over to the side a little. And let's also create a multiply node. And multiply this by 0.03. So it goes from 0 to 0.3 and back and to 0.3. Now you say, why don't we do this in the map range node? That's actually because I want to place a float curve in between here later, so you can kind of create a custom motion. Now if we play this right now, we will still see that not much is happening. This is because this attribute is actually not changing over time, so we don't even get a period. To get the oscillation we want, we actually need to add to this attribute every frame before the sine wave. So let's copy our math node and set it to add. And we're going to add 0.06. To illustrate what we've just done, first the attribute over time just stayed flat. Now we've added something every frame. So the attribute looks like this. It goes up over time. And after the sine wave, it will look like this. So we are again using a sine wave oscillation to create this effect where the endpoint and the starting point are beginning to move, then stopping, and then beginning to move, and then stopping, etc. Let's just organize this a little bit. Let's go back to the beginning, see what happens. It's still the same. I actually forgot to connect this attribute. So after we've added 0.6 to the, or 0.06 to the attribute, we want to connect it back to itself. Let's go back, see what happens. There we go. This is something. Now we're going to create a similar setup for the ending points, so they actually start moving along and don't bunch up like this. So let's create another store attribute node over here. Let's name it end, and also place it over here. And we're going to set the initial condition to 2. So the first is at 0, the second is at 2. That means the worm is 2 meters long. We're going to select this whole section and duplicate it. Connect the value to the named attribute node. And let's also change this to end. Now the only thing we want to do is we want to offset this oscillation by 1/2 of the period, essentially. This is so they have this motion that they're both catching up to each other. And we can offset this oscillation by just adding pi to the whole equation. Of course, 2 times pi is the period of the standard sine wave. So we are going to add pi to here by just getting it from this node, because we still need to add 0.06, connecting it to our add node over here, and just writing pi over here. It will give us pi automatically. And finally, we want to connect this attribute to the end input. Now let's go to the beginning and see what happens. All right. So it's definitely doing something, but I don't like the motion right now. Now I said earlier that we were going to change the motion using a float curve. And we're going to use the float curve right between these two nodes. So after the map range node. Just going to grab everything, move it over to the left, and create a float curve. What we're going to do with this float curve is actually change the shape of the oscillation. If we change this down, it has a long period where it's moving slow, and then it speeds up, and then it quickly slows back down. If we set it the other way, it's the other way around. It will go really fast and then slow down, and then stop and go really fast and slow down. So we want the first one. Let's set it to about right here. And it's very important that you duplicate this and then don't touch it anymore. If you make these two float curves different, the animation might catch up with itself and you'll bunch up the whole thing or stretch it out. Let's go back and press play. That's more like it. All right. So we need to do some troubleshooting. Of course, here the corners are maybe a bit too narrow. So we can probably do that a little better by going to our curve here and just copying this subdivide curve node. Or actually, we can put it before the trim curve and then connect this to our joint geometry. Let's just get rid of this part then. And let's go back a little bit. Yeah, so we don't want to have two sharp corners, so we can change that up a little bit. You'll notice that it doesn't update while you do this. This is because the simulation node is technically still running. Just scrubbing the timeline a little bit can fix that. Maybe change this one. Yeah, it's pretty annoying. They will probably fix it. Maybe if you turn off this, it doesn't do that. No, it still does it. Anyway, the important thing is that we have our procedural animation now. You can play around with this add value, these multiply values, and this float curve to get different results. Hi, this is me from the future. I thought I'd clarify these values you can play around with. So this add value represents the frequency of the sine wave. And what that means is that if the frequency is lower, the endpoint or the starting point has more time to move along the curve. And that usually means it will cover a greater distance. The multiply values over here represent the velocity of the starting and end point. So how fast is the starting point or end point going along the curve? Now let's unhide our surface. I have of course changed a few things, but the curve seems to be right along the surface. One thing I want to do is make it a little less thick. So let's do that by going all the way to our node we created, the multiply node over here, and just make it a little less thick. Also, let's create a few more control points here. This is so the worm can actually come in and then go over, do the simulation we're going to make after this, and it will all look great. Next, we're going to make the simulation group for the surface here. So let's create a new geometry nodes group and create a new simulation input and a new simulation output. And we just want to bring one node in between here, and it's going to be the set position node. And you might have already guessed what we're going to do. We're going to move these vertices down based on the proximity of the worm. So when the worm gets close to the surface, it's going to detect that. And every time it detects that per frame, the ground is going to drop down a little bit. And to get our geometry proximity, we're going to create the geometry proximity node. And we're also going to get our object by going to object info, getting that node, and selecting our Bezier curve. And this is important, you're going to set it to relative, because then it gets the geometry of the worm we've generated. We're going to connect the geometry to the target, and we're going to create a math node. And set the math node to less than. And let's also get our viewer node to see what's going on. Let's connect our original geometry to the viewer, and also connect this output. And we're going to let the simulation run for a little bit. Let's turn it on. Okay, so I actually need to connect this. Very smart. And we can already see that it's looking for vertices close by this worm. And we're going to pull that down a lot, so it's just barely getting those vertices. Let's leave it at 0.01 for now, and we're also going to set the geometry proximity to points instead of faces. So next, let's get a combine XYZ node, and we're also going to get a math node. And what we're going to do is we're going to move down the surface that it finds here, that's close to the worm, and we're going to move it down by 0.001 on the Z scale for every frame. So let's set this node to multiply and set this to minus 0.001. Connect that to the Z input and connect this output from the less than to the input. And we connect this vector to the offset. Also, we are just going to add a node over here, and it's going to be the shade smooth node. Set shade smooth, let's put that in between these two nodes. So let's go to the beginning of our timeline and set our simulation to play. And we're going to see what happens. We can already see that it's pushing down geometry right here, which is very good. It's leaving a nice trail after it's gone through the geometry, but there are some problems. For one, the geometry is looking very chunky, so we're going to have to up the resolution on it. And the other problem I'm seeing is that it actually seems to be kind of floating above the surface. The worm pushes the geometry down too much. So that last thing is actually fixed very easily by just taking this geometry, so that is the worm we have here, and just pushing it up a little bit so it checks for the worm, but maybe 0.2 or 0.1 meters higher. So we just get a regular transform node, and let's set it to 0.02. And we're also going to go to our base mesh and go into edit mode. And I want to edit just the parts where the worm is going to be traveling along, because I don't want to make the whole mesh super detailed. That's not necessary. So it's pretty hard to see the curve actually, but let's try it anyways. Let's put it to see-through mode and just get our select circle right here. And we're just going to select the path right here. I believe it's going that way and then that way. Yeah. Oh, shit. Yeah, it goes out like that. Maybe give it a little more room. Just want to be sure. You probably don't need that much room, but I like to be sure. So once we have our selection, we're going to click subdivide. And let's just subdivide it once and set a subdivision surface right at the end of our mesh here. So that is the geometry nodes for our surface. Let's go back to the beginning and play our simulation. All right. That's already looking a lot better. We can actually set the end time to 1000. Yeah, so there are a few bumps left, I'm seeing, but that could be because the worm actually started here. Well, actually there's another one right here. Yeah, so what I'm gonna try out is actually maybe let's push the geometry down by minus 0.0015. Maybe when it gets pushed down faster, it doesn't miss any of those and we won't get any bumps. Yeah, so the bump that was over here, that one has disappeared. I believe these bumps are here because the worm actually starts here. And the tip actually pushes a lot of the geometry down because it's more narrow. So if it were to start more at the beginning, we probably wouldn't have these bumps. We can actually test it out by just extending our starting point right here. Let's play it from the beginning. Yeah, so the grind reveal. Yeah, there are no bumps anymore. So that's actually important because the tip pushes down geometry. It won't be perfect at the starting point, so keep that in mind. Okay, so we have our simulation for the worm, we have the simulation for the ground. Let's make a material. Let's just click on our worm right here, go all the way to the end, and we're going to just add a set material node. And what we also want to add is a store named attribute. And the attribute we want to store is basically this oscillation we have here, so we can create the ridges. We're going to go to our curve right here, our float curve, and the map range node we set here, where we have the sine output. We're going to just duplicate this map range node and set it from 0 to 1 at the maximum. Oh, sorry. Yeah, 0 to 1, so it goes from -1 to 1 and now from 0 to 1. Connect the sine value to the mapped range node over here. And we're going to connect the result to the value here. And we're going to give it a name. Let's name it worm. And now let's quickly go to the shader editor, add a material, pop back into the geometry node editor and select it right here at our node. Let's add our attribute node here. Type in worm and let's create a color ramp. Connect our color. And we will see that we already have these ridges. And with this color ramp, we're going to set the colors of this worm. I always remember worms as being very pink, but they're actually more like maroon and close to red, more than you would imagine. So let's just set it all the way down like that. And the other one, I'm just going to copy this color. You can actually also just Ctrl-C and Ctrl-V this. And we can bring this up a little bit, maybe. Make it a little more bright. Kind of like that, I suppose. We can also plug it into our subsurface and up the subsurface. And also want to change the roughness a little bit so it looks a little more shiny. Next thing I'm going to add is just a simple noise check texture. I'm going to add a noise texture over here. Also a mapping node and also a texture coordinate node. Like that. And we are going to connect the normal to this node. Connect the vector over here. And let's put another color ramp in between here. And we're going to use this color ramp to make the bump map so it actually looks more fleshy and more like an actual worm. Let's get a bump node. Connect the color to the height. Connect our normal to the output. And I don't really like how this is looking right now. So we're going to change the noise texture a little bit. Let's bring the scale way down and the detail up. Let's also just decrease this bump to about, I'd say 0.2 or maybe a little bit less. Already starting to look a lot better. So let's play this. Yeah, I'm quite happy with this. For the ground texture, we also want to create a new material. And again, go into the geometry node editor and go all the way to the end and add a set material node. And let's set that to our new material. Go back to the shader editor. And we're going to just create a very simple sand texture over here. So let's get a texture coordinate node. And also get a mapping node once again. And then we're going to make a noise texture as well. Let's plug the object vector into our mapping node and plug the vector into the noise texture. We're also going to add a color ramp so we can actually see what the texture is doing. Connect that and let's see how it looks. So to get this sandy effect, we're just going to up the scale a little bit, also up the detail, and we're going to crank out the roughness over here. Next, I want to just copy this and create a new bump node. We're going to create a bump map for this material. Just going to connect the color to the height and connect the normal to the normal. Right now, not much is happening because we also have to connect this mapping node. Right, so let's do the bump node first, actually. We want to set the scale a lot higher. Let's set it to 10. And let's up the detail. Gonna set it to 7. And we're gonna crank out the roughness. Looking very rough right now. I'm gonna decrease the strength of this. So just, you kind of see that roughness, but it's not as pronounced. And then let's go back up to our original noise texture and set the scale to the same amount. And let's also up the detail on that, but keep the roughness lower. Next, we'll just give this a nice sandy color. Let's put it to a little bit yellow, and then the other side is going to be a little more red. It's maybe a little too green for my taste, so let's make it a little more orange. I guess that's fine for now. It kind of looks like mud actually. So let's change the roughness a little bit. I'm going to go back to our principled BSDF and just crank the roughness all the way up to 1. So now it kind of looks like sand. You can decrease this roughness so it looks more like mud. Again, there are a lot of procedural material tutorials on YouTube. And for this, I don't actually believe it's got to be procedural. You can just make a UV map and the geometry nodes will only distort the mesh a little bit. Playing our simulation from the beginning, let's see how this looks. There we go. I really like how the worm looks while it's on top of the sand, and it's also leaving a very nice trail over here. So yeah, that concludes our introduction to these simulation nodes. I'm really excited to do more with them and also to see what you come up with in the future. So let me know in the comments below what you think of the simulation node. Like the video if you enjoyed this tutorial, and if you've made it this far, you are a legend and thank you so much for watching.